Welcome back, ladies and gentlemen, to Let's Talk Energy, SMA's brand new virtual format. Today with Power On, where we are talking about all aspects of large scale. We are just about to start into our next session of the day. Before we do so, however, I'd like to give you some important information. In our next session, we're going to be talking about batteries. We're going to explore batteries and how batteries can expand your sales, your energy sales opportunities. And for this, I would like to welcome back, I would have to say, because he was in our last session already. Please welcome back the Head of Product Management, Central Power Conversion, Carsten Wendt. Hey, Carsten.
Good morning.
Great that you're still here.
I'm still here, yes. I'm not going away.
Fantastic. Okay, so we'll keep you for another 30 minutes. Is that a deal?
Yes.
Okay, so for all our viewers that didn't catch you in the last session, that are just watching us right now, that want to know more about batteries and the energy sales opportunities, can you just sort of start us off giving us a brief overview of what it is you do right here at SMA?
So the team and I are looking after central inverters for both PV applications and storage applications. We also have a DC-DC converter for combining both at one machine, and we also provide medium voltage solutions. So we basically wrap it up in a complete turnkey solution to make it as easy as possible for the customer. And in doing that, we obviously talk a lot with customers, understanding the market, and of course drive internal development projects to make the products better.
Now, you're a storage expert right here at SMA. Tell me, why is large-scale storage such a hot topic right now, and what growth potential do you expect there?
There's actually a good slide from the Bloomberg New Energy Finance, which actually exceeds our internal dreams a lot. So it's tremendous numbers which you see here, and we have already seen quite some growth over the last 2 or 3 years. But if you look at those numbers for the next 20 years, we see yearly additions of roughly 100 gigawatt of storage. So this is across different segments. So we have storage and residential, especially here in Germany. So we see a lot of households adding storage to improve self-consumption. But we also have, of course, this in the commercial segment with like supermarkets, etc. But we see, especially in the last years, spectacular growth in the large-scale segment in order to improve the network. And on this, I'd like to focus today, show what customers have been doing in the past, but also in the future.
Okay, so can you tell us what are the main applications? What can we see?
So in general, we distinguish between 2 main applications. So one is the power application. So the inverter is connected to a fairly small battery, so it can provide high power, but not for a very long time. And there's certain use cases where this is very helpful and needed. And especially in the early days, we've seen lots of frequency support applications, which I explain more in detail. We also have hybrid systems with a diesel generator, etc. And these diesels have a slow ramp rate and increasing or decreasing power in order to fill that gap with, let's say, rolling clouds. The storage can basically close that gap. And also we have seen applications such as peak shaving, which is for industries. They're not only paying for the kilowatt hour, they're also paying for the max consumption. So if they have a peak consumption by switching on certain loads, this can be neglected by adding some storage. So that will basically be the buffer, and that reduces the entire energy bill. So that's quite interesting. And a super big topic, which is a really future topic, is the synthetic inertia, which I will mention later on as well. The second one is energy applications. So we're talking about larger batteries, so more than an hour, so typically 3-4 hours, but can go up to 8 hours. So quite a large battery, obviously quite expensive as well. And we're typically talking about energy shifting. So we're not just providing power, we're really shifting energy from maybe mid of the day towards the evening. And people do this as a wholesale business, so basically they're trading on the energy market, so they're buying cheap energy in the morning, or in the noon of the day, and sell it in the evening. I have some good example for this. Time of use tariff, we see this for households sometimes in some markets. You pay more in the evening because there's a peak demand and energy is expensive. So by adding storage, you can actually avoid this and charge the battery when it's cheap, maybe at night, and then discharge in the evening. The other one, which is very a big trend right now, is adding PV and storage at the same location. So there's 2 different approaches, AC or DC coupled systems, which we're going to compare. And something which is also quite political is a grid bottleneck relief. So we see that grid extensions are sometimes very difficult. You have long permission process. Lots of communities are pushing back on those as well. And storage can be a very good alternative without adding extra high voltage lines.
Well, the political barriers that you just mentioned, I mean, these communities that push back the building permits, they still want to use the energy. They just don't want to have it outside their community, or what are the barriers we're talking about?
It's a little bit of like not in my backyard mentality. So everyone wants renewables, but not having a wind farm next door and not living underneath overhead transmission lines. So there's obviously the magnetic fields, and putting those cables underground is difficult as well. It's way more expensive. You need reactive power compensation. So it's actually very reasonable to think about alternatives such as storage, which provide additional benefits and not only grid relief.
Now, if we look at the past, what were the main applications there?
So the main markets over the last 3 years were the United Kingdom and also Korea, and both are somewhat an island. So one is a real island, the other one more a political island, although still connected to the mainland. So, but they have independent power networks. The UK is somewhat connected to the mainland, but very limited. And they have been adding a lot of renewables in the past. And with this volatile generation, they actually start getting problems in their network. So it's difficult for them to manage the balance between load and generation, since clouds are extremely fast, and but the conventional power plants are very slow in picking up. So you need something which actually balances out. And the easiest way in doing this is doing this by frequency. So the frequency will always change with the load and generation. And in order to do this, as this is quite a quick impact on the network, you need a fast response of the inverter. So the response times are super important and a mandatory requirement. So you will see different requirements for every market. There are also different terms. In UK, they're called fast frequency response, and some others fast control or auxiliary services. And in Germany, it's the primary control market, so you see different names for this. The German market is quite transparent when it comes to data. So on the regelleistung.net webpage, you can actually look at the data. You can see how actually the primary control is being purchased and sold on the market. There's kind of a ahead bidding, so everyone basically places a bid 3 or 4 days ahead for basically 1 day. And this service has a value somewhere between 100 euros and 500 euros. So obviously, the lower your bid, the more likely is that you actually get awarded. And but obviously, you have less revenue. And we can see that this price actually went down over the last year. Probably COVID-19 had a certain impact here as well. There's less demand, and that will also kind of impact the primary control market. And in order to be kind of awarded and participate, you have to undergo a certain pre-qualification. So people will check the machine, your design needs to be connected to the electricity market, also on the internet. And of course, there's also important terms around the downtime, because you're providing a critical service to the network. And if you're not available, there's no value in the service. So there's heavy penalties on downtime, so that people typically oversize the system, so they have one extra inverter and battery system. They have special service contracts with very fast response times to act in case of a failure, etc., to obviously avoid those penalties. Also, in short, liquidating damages, LDs.
What about the main application for today?
So what we see as a transition from frequency control markets, we see a major shift towards energy markets, such as the market in California. What we see here is that the actual net demand on the transmission network for the Californian Independent System Operator, KISO, has changed dramatically with adding solar. So you see the original load of the system was a blue line, and when we start adding a lot of solar, you see that the red line becomes the shape of a duck. So you have the morning peak, which is the tail of the duck, then you have the lower back during noon, and then you have the head, which is the evening peak. And in correspondence with that new net load, you have also different prices on the market. You see that in the morning, the price soars up to, I think, roughly $30 per megawatt hour, so that's 3 cents per kilowatt hour. In the middle of the day, it's down to 1 cent a kilowatt hour. And in the evening, again, the market price goes up to more than 5 cents per kilowatt hour. So what they do with storage is basically shifting the energy from a time where it's very cheap. So they buy energy very cheap and during noon, and then sell it in the evening where it's expensive. And that's how the market actually regulates itself. And we have a huge additions of storage in this market. And this chart is actually from 2018, and since then a lot of additional solar has been added as well, so which obviously makes this even more of a duck curve.
Okay.
So these kind of applications have a new challenge for the inverter. So response times is still important, but not so critical. It's more about the size of the battery itself. So we have a very large battery, and the very dominant technology is lithium-ion batteries, which have a very high short-circuit current. So which means the inverter needs to be protected from this very large short-circuit current. So we do additional testing for the machine at an institute here in Berlin with more than 100 kiloamps for the inverter to safely trip such a fault. And we're also developing a new solution which even allows way more than 100 kiloamps, so that for these new applications you can even have larger batteries.
Now on your slide here I can see that you are an EES Award winner 2018. Can you tell us something about that?
Yeah, it was the kind of very successful start of this product. So we had a storage inverter before this, but based on the current platform, we have achieved this award. And we have also different awards for special applications like grid forming, and there's a separate session on this as well. And yeah, we're extremely proud on this, of course, and the product is being very well received on the market. As I mentioned, quality is very important, and response times, and both are kind of our core strengths. That's why we're well placed in this market.
Let's look into the future. Next up, what trends do you see in storage?
So grid forming been kind of the birth and the cradle of general storage applications. So kind of a small ski hut, adding some solar, maybe a small wind turbine, and adding some storage, etc. So we have done these kind of projects 20 years ago. So it's not very new. But the very new thing is about actually adding grid forming for different applications. And I mean, these kind of island systems, we have done fantastic projects. Maybe some of you have seen the trailers and the breaks. We have done the Marlon Brando Island, so completely running without any diesel, just solar and battery system. And the battery inverter is actually creating that network. We have seen kind of backup systems. This can be very interesting for some process industries, like let's say chemical industries, where they have a process which takes very long to ramp up, maybe a day or longer. And if you have a grid outage, you basically have a complete batch which you have to throw away, and it's obviously very expensive. So a few outages a year already having, well, it's a good business case for storage just for these few instances. But the even bigger topic is on the right-hand side. We see a certain need for grid stabilization. So what we're going to do in all these different networks is we're starting to retire old generation assets like coal-fired power plants, nuclear power plants. And those have a turbine, a rotating mass, which basically provides some strength or stiffness to the network. By retiring those, you need something else actually picking up this job, and this is grid forming. So the inverter actually becomes able to control the network. And we're starting to add grid forming inverters, not in an island system, we're starting to add those in the connected networks to stabilize it. And we see huge demands already in Australia, which is in kind of the forefront of these kind of extreme phenomena, but we will see the same in every market at some point. And this will be very critical for the transition from, let's say, conventional power generation to renewables. And yeah, we've been very active in this segment. I think we're well placed to be one of the front runners here as well.
Can you tell us, as my last question to you, is there an ideal way, or what is the ideal way to combine PV and storage?
Yeah, we mentioned in the last session that we see already today a lot of people having co-located PV and solar, because we saw also in the example from California that there's lots of generation during noon, but then obviously a high demand in the evening. And doing this AC coupled, you're investing a lot in infrastructure. So I put this here on the slide. I hope you can see this. So you're basically doubling this up with an AC coupled system. So you have an inverter for the battery, and a transformer and a switchgear, and you do the same for also the PV system. So you basically have 2 times the system. Let's assume you have 100 megawatt of grid connection. You want to add 50 megawatt of storage, and additionally have lots of PV. So what you do, 50 megawatt of storage, you add 150 megawatt of PV, because 100 megawatt goes straight into the network and the other 50 to the storage. And then you need in total 200 megawatt of transformers. And you will oversize the PV array based on the PV inverter, so roughly maybe 200 megawatt peak. So that's a DC-AC ratio of 130%, quite commonly done today. And you have a certain round-trip efficiency. Obviously, you go from the solar panel through inverter, transformer, again transformer, inverter, and the way back to the network. So you see there's quite some losses in the system. So you have a round-trip efficiency from PV to battery to grid with roughly 91.3%. So more or less 8.7% of the yield is actually lost. Mm-hmm. So if we compare this with a DC-coupled system, same scenario, we have a 100 megawatt grid connection. So we're adding only 100 megawatt of transformers and inverters. And now we actually add DC-DC converters. And this actually allows us to add a very large PV array to this inverter, whereas the inverter can actually distinguish and can charge the battery and at the same time feed into the network. So that actually allows us to massively reduce the capex of the system, so the cost for the infrastructure. And you also have a certain gain in round-trip efficiency, because now you're actually charging the PV into the battery just through the DC-DC converter. And then from there, you go again through the DC-DC converter, the inverter, transformer, back to the network. So we have a round-trip efficiency somewhere around 94.6, so more than 3% better, which is pure money basically, really improving this system here a lot. And finally, this is a more general slide about comparing those two systems. AC coupled obviously has some advantages as well. So in some markets, you actually need extra AC capacity. So it's good to have both separately, inverter for PV and storage. We also talked about grid forming, which is already available for AC coupled systems, not yet for DC coupled systems. So if that's needed, that's obviously a big advantage here. It's quite a technical topic, but we sometimes see that PV needs to be grounded, but batteries do not really like to be grounded, and you cannot do both in a DC coupled system, so you have to decide for one or the other. And it's a well-known application, very mature, so people know what this is, and very bankable and easy for everyone to propose. But the advantages of a DC-coupled system I just mentioned beforehand is tremendous. So you obviously save a lot in cost. You also save in O&M because less components mean also less O&M of those. And also less standby losses because we have less transformers which consume power at night. And as I said, we have a better round-trip efficiency, which makes it a more profitable project.
Well, thank you very much for the summary, very easily to see and to understand. And with that, dear Carsten, I would say if you're ready, let's head over to the Q&A and see what questions came in for Carsten Wendt.
Thank you.
We are back with your questions, our questions for Carsten Wendt. And I checked in with our technical team earlier. It's really amazing. We have questions coming in from Oman. We have questions coming in from Zimbabwe. And I have to say, this is really quite amazing. Coming to you live from Niestetal, really out into the world. So let's see what questions we have. I can't see where they're coming from, but I can tell you what the questions are. So Carsten, first one for you is, what's better or more economical for PV and storage?
Yeah, that was kind of the last slide. So again, like a good lawyer would answer with, it depends. But if it's really about capex saving and having a very large, let's say, PV array and maybe limited grid connection point, then I think DC coupled has quite some advantages. As I mentioned, also with the round-trip efficiency. There's also some advantage in some markets where you have certain restrictions with a nameplate rating of inverters. That's the case, for example, in the US, where utilities do not allow you to have a combined nameplate rating which is larger than the grid connection. And therefore, DC-coupled is, well, helpful because it's a stupid rule, but it is what it is, and it helps you to get actually grid access.
Okay. Is MPP tracking affected by DC coupling storage to the PV inverter?
It could be potentially, because that's what we have seen with some designs on the market. So we're not the only one providing it, but some of them have actually kind of to disable the MPP tracking of the inverter to make it DC coupled, which obviously then results in losses from the actual solar area, which is not nice. So we developed a completely new solution. So the inverter continues MPP tracking, and the DC-DC converter is kind of a slave to that MPP tracking. So we have no losses in the MPP tracking, and we have an extremely fast responding DC-DC converter. And so that actually makes this very unique and also very easy for the customer to use.
which is, of course, fantastic. Now, next question for you, Carsten, is how do you deal with very large batteries?
As I said, large batteries have a high short-circuit current, so we're developing also a new solution to even allow the use of larger inverters and even larger batteries. And in order to reduce the short-circuit current, we're able to segregate it into 3 bus bars, and that actually allows it to use come-in fuses, which are typically rated up to 100 kiloamp, but still protects the inverter. So that's a quite new design. So if you're interested in this, just reach out to us and we can explain it.
Carsten's your man. Can DC storage be charged from the AC grid and the solar?
Yes, it's possible. We have first kind of disabled this functionality because in many markets it's not allowed yet. So because, for example, in the US there's a certain ITC, investment tax credits, which only allow you to charge the battery from solar and not from the AC. But it's a feature which is readily available and which we can deploy in a couple of months.
Next question is also fantastic, I have to say. We're going to look into the future a little bit with this one. Do you see any new battery technology that could be a game changer in the storage market? If you look into your glass ball.
Yeah, we have a pile of broken crystal balls back there. It's hard to say, but at the moment the market is strongly dominated by lithium ion. There's some new trends in lithium ion itself. So I'm personally not a chemist, so I'm not 100% sure which might be the next trend here. We in general are diagnostics, so we are open to work with different kind of battery technologies. We don't force anyone in any direction. We actually provide a service where we make sure it's compatible, so we can test the batteries together with the inverter, make sure they communicate well, so the battery management system and the inverter, so to make it a very safe project for the customer. At the end of the day, the decision is done by the customer because the battery is expensive, and of course that's why they should be able to make that call.
Of course. What would SMA consider DC-coupled storage with flow batteries?
I have seen first inquiries around this, but flow batteries haven't really taken off yet. I think we have one project only, if I'm not mistaken, with central inverted. I think it's not a very mature technology yet, and also the cost degradation, which we have seen with lithium ion, we haven't seen the same with flow batteries. They're pretty large, so if space is a certain constraint, this is an issue. Of course, they are fantastic with cycles and good for energy applications. It is interesting technology, but we don't see it yet, maybe in a few years. Okay.
How can I show the benefit for grid through storage is our next question for Carsten.
That's a good one. We have seen a lot of inquiries, especially in new markets where the utilities sometimes come up with interesting mandatory conditions, such as add some storage to stabilize my grid. So what does that actually mean? I mean, this is very, very broad comment. So obviously something which we have seen before is like stabilizing frequency. Ideally, you can conduct a grid study to show before and after adding storage. So how does the network actually improve? You can also shift energy from the noon peak to the evening. Grid forming is obviously extremely powerful, but the most complex topic by itself as well. So if you're dealing with let's say, a utility not being too familiar with this yet, it can be quite a long process. We can assist, of course, and help with dealing with the utilities. So we have a team of product managers working with utilities. But I think frequency control or, for example, avoiding the irradiance peaks from rolling clouds, for example, can be a good argument for the utility. But it's difficult to quantify this typically because it can be all or nothing.
Mm-hmm. How important is grid forming?
Very, quite short. I mean, as I said, we're still early stage, but we see most grid codes in the world actually changing to accommodate this. So at the moment, grid codes do not really allow grid forming because it behaves slightly different. It actually behaves more like a synchronous generator and not so much like a PV inverter, which is actually good, but the grid codes actually expect kind of a PV inverter behavior. But we see that a lot of grid codes actually opening up for this, and we see a huge demand. A lot of, especially markets like Australia, are really looking at this closely to use it as a very powerful tool to strengthen their networks and also being able to retire old assets like coal-fired power plants, etc.
Next question is ready for you. They're just firing in, and Carsten is able to handle them all. If you have questions for Carsten, we still have about 4.5 minutes, so you can still type in some questions. The next one is, how do you promote storage in new markets, Carsten?
Yeah, somewhat similar to the question earlier about, or my answer at least. So in some new markets, first it's important to understand what's actually the challenge in this market. So what is the problem they have? When you have understood the problem, so you can obviously propose a solution. If you don't know the problem, it's difficult to propose anything. So we sometimes see that some smaller countries, like we've seen this in Puerto Rico a couple of years ago, they were adding storage to avoid ramp rates with rolling clouds. So the storage shall close the gap so that the existing generation assets, gas turbines, diesel generators, can actually pick up with this fast movement. That could be a solution. Again, grid forming could be, but it's very complicated. And frequency control is definitely a well-understood topic to support the network.
Is there a common or fixed incentive for battery storage?
Unfortunately not. That would be too easy. I mean, we have seen this in solar actually quite straightforward. We first had feed-in tariffs, so everybody knew what he's getting, and then we had more open markets like reverse auctions and PPAs, etc. But still, the mechanisms were quite well understood. So you produce energy and get paid for it. With storage, in the beginning, as I said, we had primary control market like in Germany, so you get paid per megawatt. Then you have energy markets, you get paid maybe per megawatt hour. What we see nowadays is that one use case is not sufficient to pay off a battery. So people actually stacking up business cases. So they have not only one, they actually have 2, 3, 4 business cases sometimes. They have quite complex algorithms. So the controller actually decides, is it worth doing a frequency control now or energy shift? How much do I actually pay for the battery degradation? Because every time I cycle a battery, it kind of ages. And this is some kind of cost as well, which I have to depreciate. And so unfortunately, it's not straightforward. Some control markets are a bit easier to understand. The energy markets itself are quite volatile. And the more, let's say, assets get connected, the more the market changes. So you don't have so much investment security like you have with a PPA and storage. Within PPA and PV. So therefore, I believe it's going to be more helpful to look for PV plus storage applications where you have a combined PPA for both together. So that provides investment security, but also benefits for the network and the off-taker who actually gets the energy.
Right. Storage costs have been going down the last years. What is the main factor that could bring the battery prices down?
Demand and supply, as always. So at the moment, we see a huge demand, and supply hasn't picked up yet. But of course, storage production facilities or battery production facilities are being ramped up everywhere in the world. We see the same with electrical vehicles. At some point, they're kind of course, competition in getting batteries, but they're also creating economies of scale. So there will be more production facilities. So we've seen the same in the PV industry. So I think in 2008, actually the PV prices went up because there was so high demand, but limited production facilities. So there were even people kind of buying panels for the next 3 years and going bankrupt with this because they thought the price goes further up, but the opposite was happening. So it really comes down to production efficiencies, the mining around it, and also, of course, more volume makes it cheaper.
Absolutely. You have 1 minute for the last question. Do you have references with DC-coupled PV storage systems?
Yes, we do have our own pilot, of course, where we have tested this, but we have also commercial operating systems in the US already with this technology. It's actually running very smoothly. We're very happy about it. A lot of people are looking at it as it is kind of one of the first reference site. And also with this kind of integration which we've done, so including the MPP tracking, what I mentioned before. And we're extremely proud, and I think this is very important to help everyone in the industry, because when people see that this is working well, it is bankable, you can rely on it, then this will become a very important trend for the future.
If I would like to get more information on the reference that you just mentioned, where could I get that? Because, of course, I'm sure the person who asked the question would maybe like to know just a little bit more than 20 seconds of it's a great project that we've worked on. Where can I get more information?
Reach out to our sales and we can then provide additional information around it, which technology has been used, how it's actually being operated, what's the business case, and what kind of learnings there are as well.
Awesome. So please reach out to the sales team for more information on that. And with that, Carsten, I thank you kindly for answering all the questions around.